Alright, I want to take a look at a few limits, just to review some techniques that we have to take care of limits. First thing you can try to do is do direct substitution. Second thing is try to factor. And the third thing is look for special limits, such as, for instance, if we have sine of x over x as x approaches 0 on the limit, that's equal to 1. Also, we have one for cosine, and 1 minus cosine of x over x, limit as x approaches 0 is 0. And then the third thing that I'd say to look out for is being able to recognize when they're really asking you to find the derivative. So let's take a look at these 3 or 4 problems here, see if we can make some sense out of it. We'll try direct substitution and factoring and run through the list until we find an answer here. Alright, so the first one here we have some trigonometry. We have sine 9x over tan of 3x. You plug in a 0, you get sine of 0, which is 0, over tan of 0, which is 0 as well. So it's a 0 over 0. You can't determine that one. So first thing you can always do with these trig identities is just rewrite them. So we're going to rewrite tangent as sine over cosine. So let's split this one up. So we have sine of 9x, and we'll call it 1 over sine of 3x over cosine of 3x. Okay, and this is all the limit as x approaches 0. So if I further separate this, the cosine of 3x should be up in the denominator, and the sine of 3x is in the numerator. Excuse me, the sine of 3x is in the denominator, and the cosine of 3x is in the numerator. So let me write this down as 3 separate ones. So we still have our sine of 9x originally, and then we have 1 over the sine of 9x, no, excuse me, the sine of 3x, and on top the cosine of 3x. So let me erase this and put the cosine of 3x. Okay, so now if I think of each one of these as a fraction, well, in order for this limit, this first limit here, if we had a 9x on the bottom, then we could say that that's equal to 1. So let's just put a 9x down here. So we can do that provided that we put an x in the top and a 9 in the top. Well, let's look at the second fraction. The second fraction needs, if it had a 3x on top, then it would also equal 1. So I'm going to put my x right here. So now I have an x on the bottom and an x on top. So I haven't changed the value. X over x is still equal to 1. But I do need a what? I need to account for this 9 here. And this needs to be 3x. So I'm going to put a 3 right here. And the cosine of 3x, if I plug in a 0 for that, the cosine of 0 is equal to 1. So all of this is just equal to 1. No, excuse me. We haven't taken care of our numbers yet, have we? So this is equal to 1 times 9 divided by 3. So that's equal to 3. And that's our limit as it approaches 0. Alright, I'll stop this one here and pick up the other two.